Welcome to our quick video on polyatomic ion helper. Here the video will focus on how to memorize some of the polyatomic ions based on some natural trends. On a blank sheet of paper, I'd like you to turn it into landscape mode like so, and you'll need to divide the top part here into 6 equal parts, so draw a line to separate it in half, then cut that part into thirds like so, second side as well, and you can call these things group 6, group 7, group 14, group 15, group 16, group 17. About halfway through the page you can draw a line like this over to the second line, draw it down, and then we'll actually end up using most of this page here. So away we go. So before we actually put some polyatomic ions together, let's remember some things about the periodic table. Remember, if an element is in group 1, it has 1 valence electron. In group 2, it has 2 valence electrons. Group 13 has 3 valence electrons, 4, 5, 6, 7, 8. Now 8 is the magic number that elements like to get to when bonding. So if something has 7 valence electrons, to get to 8, when it acquires 1 more electron, that makes it negatively 1 charge. So everything in group 17 is pretty much negative 1 for a charge. Group 16, everything takes on 2 more electrons, like so. And I'm putting these numbers backwards by accident here. Let's not forget that when we report charges, we actually put the number first and then the charge. So 1 minus, 2 minus. Group 15 is 3 minus. Group 14 we don't really worry so much about. Group 13 here has 3. They lose their electrons, so they actually go positive in charge. You get 2 plus for group 2 and 1 plus for group 1. So kind of keep that in mind. We're going to first focus on the group 17 on your sheet. And here's group 17. Remember, we just said group 17 takes on 1 extra electron, so they're a charge of 1 minus. So all of the halogen polyatomic ions, chlorates and the bromates and the iodate, they all take on a charge of -1 here. So I'm going to separate this first chunk here, like so. And these are what we call oxyanions. They're anions that contain oxygen. And you can see that there's just varying numbers of oxygen. See, there's ClO4 -1, O3 still -1, now it's O2 -1, and O -1. When you have a series of them, they have the ending 8 and ite. 8 usually refers to having, you can write this in the bottom right corner of your page, right over here. 8 usually refers to having more oxygen. And the ending ite usually refers to having less oxygen. Okay, so in a series like this, we have chlorate and chlorite, which are ClO3 and O2 respectively. Now what's unique about the halogen oxyanions, many of them actually have 1 more than 3 and 1 less than 2. The one with the most gets the prefix per, coming from hyper. So they got rid of the high part, and now it's just per. So we had the prefix per, then chlorate, to say has the most oxygen. Chlorate has 1 less, chlorite has even less, and the least amount has the prefix hypo, meaning least, hypochlorite. So notice how it's 8, 8, ite, ite. The most gets per, and the least gets hypo. The same trend goes with the bromine ones. So as you can see here, we have per bromate, bromate. So they're both 8. Now we go less, it's bromite, and even less than that is hypobromite. And they are exact same as the chlorine ones right above there. And then iodate here, I honestly don't know, but iodate is the only common one that we ever actually see. It's possible to have the other ones as well here for iodine, but iodate's all we have. And it matches up right with the bromate and the chlorate. They're all ClO3, BrO3, and IO3 when they end in just 8 and no per. In addition up here, I also threw in hypochlorite. Hypochlorite, sometimes they reverse the O and the Cl. So OCl minus is also hypochlorite. It's just written backwards. Okay, and that's group 17. Now if we slide over to group 16, remember group 16 has 6 electrons. They gain 2 more, 2 minus. Our group 16 polyatomic ions are sulfate and sulfite. Notice how the 8 now went from having 3 oxygens and now it has 4. And the ite version now has 3 here. So it's just a little bit of a difference there. Sulfate, sulfite, the most has 4, and the lesser one has 3. So SO4 2 minus, SO3 2 minus. Good. Now let's slide over to group 15. Group 15, they have 5 valence electrons, and therefore they gain 3. That's why they're 3 minus. I put little asterisks here because a couple of these don't follow that. Now phosphate and phosphite are just like sulfate and sulfite, where they have 4 or 3 oxygens respectively. So it's a 3 minus charge, and it's PO4 3 minus, PO3 3 minus, just like group 15 should have. Phosphate, phosphite. Now, once you put asterisk by this now, not a 3 minus 1 charge. Nitrate and nitrite, nitrogen is in group 15, but they don't follow this trend. Nitrate ends up being NO3 with just a minus 1 charge, and nitrite has NO2 with a minus charge. Then notice how we reduced the 4 and 3 for 8 at phosphate and phosphite now. Now 8 and 8 for nitrogen is NO3 and NO2 minus. Okay. Slide over yet again to group 14. Now you might suspect we go to 4 minus. Well, the trend actually goes back to 2 now. So if you think about our groups there, it went group 17 was 1 minus, group 16 was 2 minus, group 15 was 3 minus, and group 2 goes to 2 minus. That's kind of the trend, 2, 3, 2, 1. Group 14 here is a 2 minus charge, and we have carbonate, which is CO3, 2 minus. And oxalate's kind of a weird one. It is C2O4, 2 minus. So that's your group 14 polyatomic ions. Okay, so we just covered this part of the periodic table. One more time, the charges for the polyatomic ions were 2 minus, 3 minus, asterisks, 2 minus, 1 minus. Now we're going to jump over to 6 and 7 here, and 6 and 7 follow the trends just like their buddies. 6 follows group 16 pretty closely, so 2 minus, and group 7 follows group 17 pretty well, so 1 minus. So group 7 here, the only group 7 one that we have, also found like group 17, 1 minus, is the permanganate. And just like the group 17s, all the things that were with a 4, BrO4, we called all these things perchlorate, perbromate. MnO4 minus is permanganate. Permanganate. Okay? And I think I have a little typo. Permangan. There should probably be an A right there. My bad. Okay? So group 7 follows group 17, and group 6 follows group 16. So they're also 2 minus charge. We have the chromate, which is CrO4, 2 minus. Just like sulfate was SO4, 2 minus. Not a per, just chromate, just like sulfate there. Then we have a thing called dichromate. Notice how we double the chromiums, but we don't quite double the oxygens there. It ends up being a 2 minus charge as well. I'm not going to show you how to draw this right now, so just watch. I'm going to flash it up here. Okay, so there it is. And this is what we call dichromate here in its Lewis structure. I did leave off the valence electrons, but you can see why it doesn't quite double the oxygens. It ends up being 1, 2, 3. Whoa, what am I doing? Cross those off, Mr. Schultz. 1, 2, 3, 4, 5, 6, 7. So they kind of share that oxygen in the middle, and that's why it doesn't quite double there for the dichromate. Alright, so that's our group 6 and group 7, following the charge of group 16 and group 17. Okay, next, on this part of your chart, kind of draw a little, I don't know what you call these things, a little bracket of some sort. Kind of draw it around group 14 and 15 and 16 here. And we're going to call this the add a hydrogen in front. So hydrogens are the H plus ion here. Remember back to last year that we typically said that when you add H in front like this, it makes it an acid. That's only true if it makes it neutral. So for example, a group 17 element, which we're not going to count, if you had a group 17 something like just Cl minus, put H in front, that's now called hydrochloric acid. If we have ClO4 minus and put H in front, and get rid of those charges now, this is called perchloric acid. But if you put an H in front of something with a charge, that will not get back to neutral. So if I add a H plus to a 2 minus, now the charge is still just negative. In those cases here, we have some new polyatomic ions. So we're not going to include group 17 because adding H plus to them will make them neutral. And we're also not going to do it to the nitrate or nitrite. Adding H plus to those guys there turns them into acids and neutrals. So you have nitric acid and nitrous acid, so we're not going to do them. But pretty much everybody else here, when you add H in front, they become a different ion. And they're named actually pretty easy. So let's take carbonate here, which is CO3, 2 minus. And if you add a H plus in front of it, H plus, the new charge now is just minus 1, so HCl3. And this has two names. It's either called hydrogen carbonate, or it's also called, bicarbonate. And this one's actually probably the more common one, the bicarbonate there, like sodium bicarbonate, which is baking soda. Okay, let's take another one here, like sulfate and sulfite. If I add a H in front of this, sulfate's charge of SO4 2- becomes just a minus. You have HSO4, and that is called hydrogen sulfate. And notice how these things are not neutral. That's why we can still call them by these polyatomic ion names and not acid names. And sulfite there, HSO3 minus, that is called hydrogen sulfite. Like so. So, whenever you have a polyatomic ion with a hydrogen in front of it, you really just reduce the charge by, or increase the charge by 1, so make it more positive, and you name it with the hydrogen in front of the polyatomic ion's name. So that's pretty simple. Okay, lastly, we're going to go to this part of your sheet now. We're going to call this the others. These are just important other ones to memorize. And here they are, and just list them down. We have ammonium, NH4+, hydronium, H3O+, and this is only going to be used in the acid-base chapter, so that's not really one you have to worry about right now, I'll tell you that. Hydroxide, we do need to know, even though it's acid-base stuff, it does become part of ionic compounds very nicely, so hydroxide is OH-. And then we have cyanide, which is Cn-. And then we have acetate, which is C2H3O2, just minus, not 2-. And then we have peroxide, which is O2, 2-. And we'll talk about this in a lab coming up. And then we have thiocyanate, which is SCN-. And it's kind of weird here. I don't know why they really did it the way they did it. You have the CN- there. And whenever you have a sulfur, that's what the prefix thio means there. I'm not sure why they didn't call it thiocyanide, but it's not. It's thiocyanate. And the reason I have you memorize these two is because they are used in our labs, so I want to make sure you know those ones. Okay? So this is your little helper to memorize some different polyatomic ions. So use this little sheet here to kind of memorize some of the trends in the polyatomic ions. Great job.